Ladies and gentlemen, so today we're going to take a look at scale drawings. So we're going to define what a scale drawing is and use unit scales to figure out actual size of objects. There's not going to be any homework assignment attached to this that's like a worksheet, but you will do the IXL assignment. I know this is labeled as 6.6, but your notes really are 10.6 labeled here on your end. All right, so let's get started. What is a scale drawing? So scale drawing or scale model gives the relationship between the drawing and the model's dimensions and the actual dimensions. So we have an example below where the scale of 1 millimeter is equivalent to 10 millimeters. So that means anything with the size of 1 has a size of 10 in the real world. Right? So we can draw things on a scale like you see in this drawing of the horse in comparison to the real horse. So riding a scale. Every few years, the Grand Place in Brussels, Belgium is decorated with large floral carpet made of begonias. Before making the carpet, designers make detailed scale drawings. Suppose the floral carpet is to be 40 meters wide. A designer creates a scale drawing of the carpet that is 20 centimeters wide. Find the drawing scale. So the ratio that they've set up for us is that 40 meters on the real carpet is going to compare to 20 centimeters on the scale drawing. So what we can do is we can simplify this simplify this scale down. Instead of looking at it as 40 meters to 20 centimeters. Both of these are divisible by 20. So I know that I have 2 meters being represented for every 1 centimeter in the drawing. Writing a scale without units means that the units have to be the same. So in the last problem, we wrote the scale with units, where it said 2 meters to every 1 centimeter. But if we wanted to write this without units, we would need to have them both in meters or both in centimeters. Because centimeters is the smaller value, that's the one we're going to go with, and I'm actually going to flip this around to have the centimeters written first and the meters written second, because generally when we write scales, especially scales without units, we have the smaller measurement written first, and then after the colon is the larger measurement. Now, to transform this, or to scale this into just centimeters, I'm going to write this as a fraction, so 1 centimeter to 2 meters in fraction form. And then I'm going to remind myself that 1 meter converts into 100 centimeters. So my unit of meters cancels out, and I have 1 centimeter is to 200 centimeters, because I would do 2 times 100. So my scale without units would be 1/200. Example 1. On a set of blueprints for a new home, the contractor has established a scale that states 0.5 inch equals 10 feet. What is the actual length of the living room whose distance is 1 inch on the blueprints? So we know the scale they give us is 0.5 inches to 10 feet. And on the blueprint, we're given a length of 1 inch for the living room. And we want to know, well, how many feet is that in real life? We can utilize our knowledge of cross multiply and divide to solve this proportion. So I can take, and instead of a question mark, I'm going to use the variable x here. So x feet. So if I multiply my diagonals, I would have 0.5x equals 10. And then I'm going to divide by 0.5. And then I end up with an answer of x equaling 20. So that means the length of the living room is 20 feet. All right? Example 2, why don't you try this one on your own? So pause the video and then press play to see the answer. So on a set of blueprints, we have the same scale here. 0.5 inches is equal to 10 feet. We want to know what is the actual width of a living room whose distance is 0.75 inches on the blueprint. So we can say 0.5 inches is to 10 feet equals 0.75 inches is to x feet. Cross multiplying here, I get 0.5x equals 7.5. I divide by 0.5, and I get x is equal to 15. So that means the width of the living room is 15 feet. Last example, on a set of blueprints for a new home, we still have the same scale, that's 0.5 inches is to 10 feet. The buyer would like the kitchen to be 18 feet in length, so how long should the kitchen be on the blueprints? So setting up our proportion like we did the last two, 0.5 inches to 10 feet. This time though, we're trying to solve for the size it would be on the blueprint, so the inches, and we're going to be given the feet, so the denominator of this. We're still going to cross multiply. I'm going to do 0.5 times 18, which is 9, 10 times x, so 10x, and then I divide by 10, and I get 0.9 is equal to x. So that means on the blueprint it will be 0.9 inches long. All right, and that is all for scale drawing. So now you can work on the scale drawing IXL that is linked below this video. Good luck, and let me know if you have any questions.